do the extra part on the three on the pretest sample. I struggled with
Here we go. When you gotta get your correcting, after you get done correcting, and you shut that meeting.
I wasn't sure if you were talking to me.
What are your
It's 100 and 400.
sweat? What are you something?
Yeah.
What do you want?
108 grade.
That's just
What's sweat? Let me. Sweat.
This was what, 13A?
Yes.
Okay. I don't know.
All right, number one, spring. Hayden, number one,
70%.
70%. Number two has two parts, the mean and the median. Emma Martin,
The mean is 98.5, and the median is 98.6.
yeah, mean is 98.5, median is 98.6. Three, Kavard,
24 feet.
24 feet. Four, Anna,
$12.30.
$12.30. Five, Liam,
128.
five, I have 50 miles an hour. Yes, so
Do you have to finish IXL?
it shouldn't have taken you that long. Oh, well, why would you ask? Six, then, should be what, Reagan? 26 inches. 26 inches. Number seven, Sam,
I got 0. It's equal to 0.
X should be less than one, which means an open circle at one going to the left. Number eight, David,
I have no. Or no, I have y equals -1 x 2 over 1.
you should get Y equals 1/2 X minus one. Y equals 1/2 X minus one. Number nine, Emily Robbins,
1/4.
1/4. 10, Lucy,
70 inches.
70 inches squared. 11, Christopher,
40.
11 should be 35 inches squared. I'm guessing it's half of what number 10 was. Number 12, Avery, angle dab is
119 degrees.
119 degrees. Number 13, Kelsey,
417 and 41.
the percent is 41 2/3%. The decimal, I actually have 0.41 repeater 6, which you just round to the nearest thousandth, I'm guessing, which is probably fine. I don't know what the direction's at. 14, Ike, 96 inches cubed. 15, Conrad, 7. 16, Spring, how are we doing? 16, Carter Riker.
3yx over 1y.
It should just be 3xy. 3xy. 17, Lila, 5'6". 18, Carter Riker, or Carter Mochek.
I got positive 12,000.
I have 1.2 times 10 to the -6. 1.2 times 10 to the -6. 19 then is 2. 19 is 2. And 20 should be 3/7. 20 is 3/7. Adam, 14 was 96 inches cubed. Hayden, 5 was 50 miles per hour. Avery,
What was number 17?
17 was 5.6. Emma,
What was 4?
4, $12.30. Reagan,
What was number 13?
13 was 0.41 repeaters, 6, and then 41 and 2/3%. Sam,
I have to leave early today, so when you're doing the corrections, can you put on the camera from the classroom so I can watch it?
baby. Not been working very well for me lately. David,
What was 14?
14 is 96 inches cubed. Kelsey,
What was 18?
18 is 1.2 times 10 to the negative 6. Riker,
It's 9 inches.
9 is 1/4, 10 is 70 inches squared. Robin,
Can you do number 11?
can I do number 11? Sure, let's start with number 11 again. I would strongly suggest, recommend, ask that you get yourself a separate piece of note paper, jot down some notes for yourself. This was which one, number 11? Is it 11?
Yeah.
Robin, was it 11?
Yeah.
That's on this page then. Area of triangle ABC. So I'm going on the premise that you wrote down the formula for the area of a triangle? All right, very good. See, we're already on the right path here. Which is what?
Area equals 1/2 base times height.
Area equals 1/2 base times height. Then I'm going under the premise that you saw that it asked you for the triangle ABC, which is ABC, this triangle here, correct? That's the triangle we're looking for. And then I'm going under the assumption that you remember when we talk about areas of triangles, we use the word B and H, base times height, because the base and the height have to do what? Ladies and gentlemen, why don't they just put side times side or base times side? It's base times height, which in math means they make a right angle. So the first thing I do is I look for the right angle. Oh, there it is. And what two lines form that right angle? 7 and 10. Area equals 1/2 of 7 times 10. Half of 70 is 35. You find that right angle, and you find the two numbers, even though this 10 stops here, it doesn't matter, it's still gonna be that. This 7 inches could have been drawn right in here, and it does the same thing. Might as well do number 10 while we're there. Area is base times height for a parallelogram, and that's the same thing, except it's not cut in half. The base is 10, and the height is 7, so the area of the parallelogram is 70. You don't cut it in half. I think they're trying to get you to see with that parallelogram that a triangle is actually cut is exactly half of what the parallelogram area is. That's why we use that formula. They just love that. Christopher Anderson,
Could you do number 5?
I would love to do number 5. Every fiber in my being. Is that the speedometer on Maury's car?
Yes.
Number 5, speedometer on Maury's car shows the speed in both miles per hour and kilometers per hour. Using 1.6 kilometers as the equivalent for 1 mile, that is your unit multiplier, by the way. That tells you the two things that are equal, 1.6 equals 1 mile. You are to convert 80 kilometers per hour to miles per hour. So, when it comes to unit multipliers, conversion fractions as they're called, what's the most important thing?
Labels.
Labels. So did you take this and make a fraction out of it? 80 kilometers per hour, 80 km, the word per is a fraction line, per 1 hour. And then which of those labels am I changing? I want my new thing to be in miles per hour. So do I cancel out kilometers or do I cancel out hours? Kilometers, which means in my unit multiplier, I have to recalculate this. Where does kilometers have to be? Down here, because you're canceling out kilometers. What goes on top? Miles. And here it tells you what goes next. 1.6 goes next to kilometer. and 1 goes next to mile. Kilometers are crossed off. You are gonna take 80 and divide it by 1.6. 80 divided by 1.6. Move the decimal, move the decimal. It ends up being 50. 50 what? 50 miles per hour. It's just a matter of getting those labels crossed off. No big whoop, as they say. Forging ahead. Look, we've already done 3. Feel as though we've made such great progress. Liam,
Can you do number 14 for me?
love to do 14. One of my favorite problems of all time. Wow. Also one of the easiest problems of all time. What is the volume of a rectangular prism? Length times width times height. What did you do? Did you find surface area?
Yeah.
I don't ask for surface area. You just take 8 times 4 times 3. We're gonna ask you for surface area to find out. This is way easier than that. 4 times 3 is 12. 12 times 8 is 96 cubed. Boy, we are speeding right along here. Riker,
Copy, Mr. 15.
can I do 15?
13.
Can I do 13? Who can help me out on 13? How do I change that to a percent end as a decimal? David?
12.
You're taking the fraction 5/12, which we know is nothing more than a glorified division problem, and I am dividing 12 into 5. Spring, how we doing on kind of finding that assignment? Still can't find it. So, Carter, just move the decimal up. 12 goes into 54 times, that's 28 or 48. Subtract, I get 2. 12 goes into 20 1 time, which is 12. 12 goes into 80 6 times, which is 72. And I keep getting 8s, so that means I'm going to keep getting 6s up there. So my decimal is 0.416 repeater. Now, Kelsey, you rounded it to 7, which is what it would be. If they ask you to round to the third decimal place into the thousandths, that would be 0.417. But the question is, how do I make that a percent now? Right,
Move the decimal.
right. You need to move the decimal 2 places, which is 41. But we don't, ladies and gentlemen, usually try to stay away from decimals and percents being mixed together. Okay? So you just have to think, what am I left with here? A 0.6. What is 0.6 in fraction form? 2/3. So this is 41 2/3%. We like to change that decimal to a fraction if we can, because this is actually, anytime you can use a fraction, it is by far more accurate than a repeating decimal. Because you can't really do stuff with repeating decimals because they go on forever and ever. So the note I leave myself for 13 is divide it out. If you're going to get those sort of answers there, it should not be too tough. David Pavlik, ladies and gentlemen.
Could you do number 6, please?
Oh, I thought I just did number 6.
You're fine.
Oh, does 6 have to do with number 5? What are the lengths of a diagonal in a rectangle that is 24 inches? Did you draw that rectangle, David?
Yeah.
So here's the deal. Here's my rectangle. Doesn't matter, here's my diagonal. It is a 10 by 24, and you want to know what that length is there. By the way, a rectangle has a right angle here. I want to know this length right here. Automatically, this is a right triangle, David, which should make you think Pythagorean triple. Does it work out? I don't know. Is there a 1024? There's not. However, what can you do to 10 and 24? Cut them both in half. You get a 5, 12. What's the other one with 5 and 12 up there?
13.
13. But it's not 13 because that's the small triangle. You then have to redouble it, get back to where it started, which was 26. I'm surprised nobody asked me about number 8. Conrad? Eight. Why did you do that? The $120 repair bill included $36 for parts and the rest for labor. What percent of the bill was labor? Ladies and gentlemen, I can only help you with this so many times before you got to pick up on this. You need to just get used to using a percent box on it because it's really, if you just break it apart, it is not that hard. And I'm assuming you did, Maya, did you? Did you put labels up here? This is percent, this is dollars. What things am I comparing with my little thing here? I have parts and I have labor. Parts plus the labor is your final cost. Your final percent is always 100%. How much was my parts, how much was my labor, and what's my final? Well, the total bill right here was $120. I know $36 were for parts. Which other one can what other box can I figure out? You spent $120 for everything, and 36 is for parts. How much is the other one? How did you figure that out?
Subtract.
Just subtract it. And then which one of these am I looking for? I am looking for what was labor. That's my other thing. I really don't need this part of my grid anymore. What number over 100 equals 84 over 120? So ratio, equal proportion, whatever it is. How do I go from 120 to 100? I don't know. So what's the first thing I try, Kavari? Can I? What goes into both of those? 4 goes into both of those. If I do 4, I end up with what? 21 over 30? How do I go from 30 to 100? I don't know. So then I try to reduce again. The right number that goes into 21 and 30? 7, I'm sorry, what? Did you say 7? No.
3.
3, right? If you do it by 3, you get 7 over 10. Can you go from 10 to 100?
Yes.
Absolutely, it's times 7. Wait, I'm sorry, it's times 10. I'm getting lost in my numbers here. So I do my 7 times 10 and my top number is 7. This is 70%. I really thought somebody would ask that number 8. Carter Bocek.
Number 18.
Oh, 18. And then did you by chance look any notes about multiplying time doing notation?
Oh, I took 4 zeros and then both of them.
Can I ask why you would do that? How do you multiply with scientific notation? It does not get any easier than this, children. You take the 2 left numbers. What's 4 times 3? 12. You write down times 10. And when you multiply by scientific notation, what do you do with the exponents?
Sure.
Add them. -4 and a -3 is a -7. Voila. Unfortunately, it's wrong. Why, Christopher?
Because you can't have a 12. It needs to be.
Yeah. So what do? It's an easy fix. You simply take the decimal, move it from here, put it right here, make it 1.2. And if you move that decimal, you just have to adjust that. You made this one smaller, so you make this one bigger. It ends up being -6. None of that ugly multiplying and blah, 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 yada, yada, yada stuff. It's piece of cake. Lucy?
Can you do number 17?
Number 17. I sure can. Lucy, what do we know about negative exponents when it comes to fractions? If you don't know that, we ain't gonna get anywhere with this. Somebody, what's the rule with negative exponents that you're gonna write down for yourself there, David?
You flip it.
You flip the fraction over and make the exponent positive, which means this becomes 2/3 to the first power. Fortunately, anything to the first power is itself. So you just have 3/2 minus 2/3. And what am I gonna have to do? Make common denominators, which would be 6 and 6, 3 times 2, 2 times 2, 2 times 3, 3 times 3, 9, 6 minus 4, 6. Everybody says is.
5, 6.
Everybody says is.
5, 6.
Everybody says is.
5, 6.
Look at you. All together. Spring, how we go? You find it yet? Maybe it's in your locker. How do you know? When did you check? Huh? Came to school or came to this class? Really? Yeah? Oh, where would it have, how would it have gotten out of your book there? On the table. Clark!
Can you remember 8?
I don't know. I think I probably could. Let's try. Oh, thank you about it. What would be my first step in problem number 8, Liam?
See where it crosses the y-axis?
Well, but first, before I do that, just in order to get myself organized, I would write what? Sam?
Y equals mx plus b.
Yep. I would write the slope-intercept form of a generic equation. So that's the equation you have to use. You just have to find out what number you put in for the letter B and what number you put in for the letter M. The y and the x are going to stay because they're part of the equation. And then the first one, Liam, is easy because I find the letter B because B is the y-intercept. So you look on the y-axis and see where it crosses, which is right there. So the letter B is -1. I am halfway done with this problem, children. I just need to find what goes in front of the x. How do I find what goes in front of the x? First thing you do is you make that triangle super big so everybody can see it. Then you need to make a triangle out of two dots that connect, like right here and right here. I am making this my triangle. And my slope is how high the triangle is over how wide that triangle is. Rise over run. Change in x or change in y over change in x. How high is it? 1. How wide is it? 2. It's going uphill, so my slope is positive. My slope is positive 1/2. So I go back to my thing and I just have to put 1/2 in for x, or in front of x. And there is my equation. My equation is y equals 1/2 x minus 1. Whew. We are making some serious, and I mean serious progress today. Twice.
Can you do number 16?
Why not? Ooh. Let me rewrite it over here big so we can see it. 6x to the -2, y x to the 5th, x equals y over 2x squared y. There are multiple ways to approach this. Who's got a suggestion for me what I would do first? Lyle, what would I do first?
Make the negative exponent positive.
Sure, how am I gonna do that?
You're gonna switch the sides.
Okay, you're gonna take this, because we don't like negative exponents, and just move it to the bottom and make it x to the +2. So it's now gone up here. Now what? Liam, what would you do?
I divide 6 by 2.
Right, so 2 and the 6 cross cancel, leaving you with a 3 on top. Then what would I do? Ike, what would you do next?
Find the 5 X's and the 2 X's on the bottom.
So what am I left with when the smoke is clear? Here's what I would do maybe if I were you. X squared means you have x times x. X squared means you have another x times x. What do I have on top? 5 x's. And what happens? These 4 x's cross off with those 4 x's to leave you with a x on top. I've done rid myself of all these x's now. And then what happens? There are 2 y's up here, with 1 y down here. This one would cross off with that one, and you're just left with a y on top. 3x y is all that's left. Spring, you don't feel any of this is worth jotting down? Just thought maybe. Just maybe. Math is not always easy. Hayden,
Can we do 20?
I hope so. Hayden, you know what I'm gonna ask. What type of an equation is this? It's a combo of what, the type 2 things? Ah, yeah. And so what am I gonna do to solve it? Opposite of those are subtract and divide. Right? Opposite of multiplication is divide, opposite of adding is subtracting. So first thing I'm gonna do is subtract 3/4. Subtract 3/4. Which means I gotta make common denominators. This times 2, that times 2, I get 9/8 minus 6/8. Hayden is,
3.
what's that? Yeah, 3/8. And what does 3/8 equal? 7/8 x. Now, this is the part where I say for the umpteenth billionth time, how do you get rid of a fraction in front of a letter? And dividing means you flip and multiply. So, to divide by 7/8, I flip and multiply by 8/7. Multiply by 8/7. These cross off, you're left with just an x. And cross canceling here, these 2 8s go away, and you're left with 3 7s. You find that as exciting as I? Maybe more so?
Yes.
A tender little middle there. Again, these don't change, ladies and gentlemen. It's the same thing we've been doing, have done, will do. Will do. Same thing for this one. We talked about this yesterday. Also an addition and a multiplication. So also to solve it, you're going to subtract, and divide by the 0.2. What is 0.4 divided by 0.2? Move the decimal, move the decimal. We'll get that 2. Did I get that right? Lucy,
Can you do number 3?
who?
3.
Number 3. Oh, number 3. We didn't do it already. Oh, yeah, I'm wondering if people are looking at that one. I don't know what, where the problem is on this. This is not really a shadow problem with us. It is a shadow problem. Here's just the gist you gotta know. A vertical yardstick. Here's my vertical yardstick. Stuck in the ground. Cast a 24-inch shadow. Now, you kind of have to know that a yard is how many inches?
36.
36. Well, you know this is 36 inches. Why? Because it says it's a yardstick. And it casts the shadow that is 24 inches. And that is similar to a flagpole. Watch this. That casts a 16-foot shadow. You want to know how tall that is. Those, even though I didn't draw it very well, are similar shapes. And similar shapes are proportional, or they are equal ratios. Please fill in your ratio box, doesn't matter how you do it. Small triangle, the big triangle, height of it, to shadow of it, it doesn't matter to me, it all works out at the end. Small triangle height is 36. Small triangle shadow is 24. Big triangle height, we don't know, but big triangle shadow is 16 feet. So you know this is your equal ratio. 36 over 24 equals what number? Over 16. Well, that doesn't work out, does it? Kovarik, so what do I have to do? Let's reuse. What number goes to 24 and 36?
12.
12. Let's do the 12. This gives you 3 over 2. And look, lo and behold, 2 times what is 16? 8. So 3 times 8 is 24. The height of my triangle is 24. Now notice that's in feet. This is feet, these are inches, it doesn't matter as long as you keep these consistent. Whew, I'm completely and utterly exhausted. It isn't nice to have that. Good thing when you get home from school, you'll go out baseball game tonight?
Track meet.
Oh, track meet.
We should warm up our legs for one.
Yes, you should. When you get to the track, I recommend warming up your legs. Avery.
Can you do number 12?
I need to go. Is that on the sheet way on top? Oh. Again, children, this, ladies and gentlemen, here is something, jot this in your notes, kids. When you have a parallelogram, you just need to know these things. And I'm going to get rid of this middle line. Get rid of this so you know, so it's not in the way. Because we're not talking about that. Paul just talks about a parallelogram. When you have a parallelogram, the opposite angles are equal. So it said that, and this doesn't matter, but this might be what they asked you. Angle B is 61 degrees. Angle B is 61 degrees. This is 61 degrees. So this angle would also be 61 degrees. They're just equal. Now, the other thing you need to know is that when you have a parallelogram, the adjacent angles, which means the angles that are right next to the ones they have that share sides, this angle here shares this side with this, are what's called supplementary, which means they have to equal 180 degrees. So 61 plus what number is 180 degrees? You end up with 119 degrees, which means this side is also 119 degrees. It's just the way it works. And you have notes where you can jot that down, so I think they're spreading manure on the field. Is that what that is?
Yeah.
One of the blessings of being growing up in a farm community. Good firm smell of nice soil. How many more we have left to do? Anything going on? Any of them?
Can you do number 20 again?
Who?
Number 20 again?
20 again?
Yeah.
Must be weird.
Wait, which part didn't we get here?
Like the set, like where you like flip it, like at the bottom, where
Well,
it's like 8,
Well,
7,
if
6.
it helps you here, Avery, I mean, it helps you to think about it this way. I will do it the other way around, but it just means you gotta write down a whole nother step. So you understand the minus 3/4, right? You get rid of that, and this is 6/8. So you understand where 3/8 comes from, right?
Yeah.
You just don't get why flipping and multiplying works?
Yeah.
Okay. Well, Avery, what type of an equation is this right now? 7/8 times x. Okay? So it's the opposite of multiplication?
Divide it.
Dividing. So how do I divide 7/8 by 7/8?
8 seconds.
Well, to divide this, I write it out like this. 7/8 divided by 7/8. What do I do to divide by 7/8? I flip the second fraction and multiply. So it ends up being 8/7. So that gets rid of my 7/8 on this side, but what I do to this side, I have to do to that side. What did I do? And multiply by 8/7. No, that's what flipping and multiplying is, it's division. I can't really go anymore. Spring, did you find that again? You looking at the book? How many more we got? Yes, Haven. Did I already do it? Is this a do-over of a do-over? Oh, I love this problem. Exponents have to be done first. Hey, so what is 4 to the 0 power, ma'am? 1. What is 3 to the first power? 3. What is 2 to the second power? 4. Here's where everybody goes wrong. What is 1 to the third power? 1. 1 times 1 times 1, ladies and gentlemen. No matter how many times you multiply 1 by itself, you're always going to get 1. And then please make sure, okay, please make sure, I don't think it matters on this one, but when it comes to adding and subtracting, you need to work from left to right. In this case, I don't think it matters, but it would for some other ones. 1 plus 3 is 4. 4 plus 4 is 8. And 8 minus 1 is 7. See, there's your notes to yourself. Hey, that 1 to any power is just 1. Hey,
Can you use number 7?
there's a chance. I didn't do it already?
No.
Solve and graph. Well, Avery, this is the same thing. This is the same thing as if it were an equation. If this was an equal sign, what would you do? Solve or add? Opposite? Think opposite.
Subtract
Subtract what?
2.
2. And bam, subtract 2, I get 1. It's not an equal, it is actually a less than. I just put the less than sign back, and that's the answer. Graphing it just means this. Here at 1, it's an open circle. Why isn't it colored in? Because there's no equal sign down there. And it is all the numbers less than 1, which goes this way. Anything else? We're so close. Wait, let me see where we're at. Nobody has an issue with his sales tax or probability? Now forever hold your P's and Q's. How about this? We already did those. Is there something we didn't do on this page? Did we do them all? Oh, we
We
did.
didn't do 9 and 2.
We did not do 9 and 2. I don't think I need to do 2, that's just ugly math. 9, just for fun. I thought I talked about this before. You are flipping a coin and rolling a number cube. What what is the probability of getting ahead and an even number? The probability of both of those happening is their probabilities multiplied together. Probability of getting ahead, how many sides to a coin are there? 2. How many are heads? Only 1. Probability of 1/2 to get that. An even number, well, a cube is a 1, 2, 3, 4, 5, and a 6. Of those 6 things, how many of them are even? 3. Which is also the same as 1/2. The probability of both of those happening are those two probabilities multiplied together, which would be 1/4 of the time. I am exhausted. I wonder if it actually works here. Hold on a second. See what we're at here. Oh. See if it stopped. Oh, look, it should still be there. Stop record.